There's a conversation I've had probably 200 times in the last few years. Someone tells me they use Tor Browser for privacy. I ask them what they think their ISP sees. They say confidently nothing, it's encrypted. And then I have to explain that their ISP knows, with high confidence, that they are using Tor, approximately when, for how long, and how much data moved. They just don't know what they did inside it. That distinction between content privacy and metadata exposure is the thing that breaks most people's mental model of Tor. So let's build a better one. By the end of this, you'll understand exactly what your ISP sees when you fire up Tor Browser, what they don't see, and the specific techniques that exist to change both sides of that equation. Start with a simple picture: your computer, your router. Your ISP, the open internet. When you open a normal web page, your computer sends a request through your router, which hands it to your ISP, which routes it to the destination. Your ISP sees the destination IP address. They see the DNS lookup that preceded the request. And if the connection is not HTTPS, they see the content. With HTTPS, which is now the vast majority of web traffic, they see only that you connected to a specific server and how much data passed. When you open Tor Browser, that picture changes in a specific way. Your traffic no longer goes directly to the destination. Instead, it goes to a Tor guard node, which is the first of 3 relays in a circuit. That connection is encrypted with TLS, and it is encrypted multiple times in layers that each relay peels back like an onion, which is where the name comes from. The destination on the open internet sees a request coming from the exit relay, not from you. That's the privacy benefit? But pay attention to the first hop. Your computer connects to a guard node. That connection leaves your ISPs network. Your ISP sees it. Your ISP can see the destination IP address of the guard node, and the list of Tor guard nodes is not secret. It's a public directory. Anyone can download it. Your ISP can trivially cross-reference the destination IP of your connection against the published list of Tor relays and conclude, with near certainty, that you are using Tor. This is not a flaw. This is Tor working as designed. Tor was built to protect what you do, not to hide the fact that you're using Tor. Those are different threat models, and the project has been explicit about this from the beginning. The ability to resist the stronger threat, hiding the use of Tor itself, requires additional tools. Before we get to those tools, I want to make sure you understand exactly what your ISP can infer when they see your Tor use. They see the timestamps of your Tor connections. They see the volume of traffic you push through Tor. They see the durations of your sessions. They see the rhythm of your usage. How often, at what times of day, from what devices on your home network. They cannot see the content, the destinations you reach, through Tor or the specific activities you engage in. But they have a behavioral fingerprint. In some jurisdictions, this behavioral fingerprint has consequences. There are countries where Tor usage itself is legally sensitive. There are contexts, certain workplaces, certain networks, certain employment scenarios, where simply being observed to use Tor is enough to trigger attention. There are also passive surveillance systems run by state-level actors that compile lists of Tor users based on ISP-level observations and correlate those lists against other activity. So if your threat model requires hiding the fact that you use Tor at all, Tor Browser alone does not achieve that. This is where pluggable transports come in. Pluggable transports are obfuscation layers that wrap the Tor connection in traffic that does not look like Tor. The Tor project has developed and maintains several of them, and each one solves a slightly different version of the problem. APES-4 is the most commonly deployed. It wraps the Tor protocol in a random-looking byte stream that does not match any known protocol signature. To a passive observer, including your ISP, an APES-4 connection looks like encrypted gibberish. It's not TLS. It's not a recognizable application protocol. It's entropy. This defeats simple pattern matching. It does not defeat a sophisticated traffic analysis that notices your connection is to an IP address known to run APES-4 bridges. That's why APES-4 bridges are distributed privately, through the Tor project's BridgeDB and through word of mouth rather than from a public directory. Meek is a more interesting transport. It uses a technique called domain fronting. Your Tor connection is tunneled inside a TLS connection to a major cloud service, historically Azure or Google's Edge network. To your ISP, it looks like you are connecting to, for example, a Microsoft service. Inside that TLS tunnel, the actual destination header routes your traffic to a Tor bridge. The cloud service acts as a relay that can't be easily blocked without blocking huge swaths of legitimate traffic. Domain fronting has been increasingly restricted by major cloud providers. In recent years, SOMIC is less reliable than it once was, but it still has use cases. Snowflake is a newer transport that uses WebRTC, the peer-to-peer video protocol used by browser-based video chat. Your Tor connection gets wrapped in what looks like a WebRTC session to a volunteer's browser somewhere in the world, which then relays the traffic into Tor. This is genuinely hard to block because WebRTC is used by legitimate services everywhere, and the volunteer relays change constantly. Using any of these transports configured through the bridges, options in Tor Browser, changes what your ISP sees. Instead of a connection to a known TorGuard node, they see a connection to an unremarkable-looking IP address carrying traffic that does not match the Tor signature. They can still see that you're transferring data, they can still see timing patterns, but the conclusion that you are using Tor becomes significantly harder to reach. Now let me add a complication. Even with pluggable transports, your ISP still sees metadata. They see how much data you send and when. And there is a class of attack called traffic analysis that operates purely on metadata. If a well-resourced observer can watch both ends of a connection, your side and the service you eventually reach through Tor, they can correlate the timing and volume of traffic and potentially link you to your activity despite the anonymity. Tor is not designed to defeat a global passive adversary, an entity that can observe traffic everywhere simultaneously. The designers have been transparent about this. The specific threat model Tor protects against is a local adversary who can see some of the network but not all of it. If your ISP is the only observer, Tor with pluggable transports is usually enough. If a nation-state level observer can see both your ISP and the destination server, Tor provides weaker protection than most users assume. There's another layer worth mentioning, DNS. Even outside Tor, your ISP often sees your DNS lookups, which reveal the sites you visit before the HTTPS connection starts. Tor Browser handles DNS through the Tor network itself, which is good. But if you use Tor for some traffic and not others, the non-Tor traffic still goes through your ISPS DNS or whatever DNS you configured, and those lookups are visible. Configuring DNS over HTTPS or DNS over TLS for your non-Tor traffic helps with this, but it's a separate problem. Now let me address a common misconception. Some people layer a VPN in front of Tor, thinking that hides their Tor usage. The logic is, your ISP sees you connect to a VPN, not to Tor, so they don't know you're using Tor. This is partially true. Your ISP sees only the VPN connection, but the VPN provider now sees you connecting to Tor, and you've just traded one observer for another. Whether that's an improvement depends entirely on whether you trust the VPN provider more than you trust your ISP and on whether the VPN keeps logs. Most commercial VPN providers, despite marketing, log more than they admit. Independent audits of VPN logging practices have repeatedly found discrepancies between stated policy and actual implementation. The more defensible architecture, if you need to hide Tor usage, is the pluggable transport route. You keep the trust model simple, you don't introduce a new logging party, and the obfuscation is purpose-built for exactly this problem. Let me also be clear about what Tor Browser does right, because I don't want to leave the impression that it's broken. For the default threat model, which is defeating tracking, defeating censorship of destination sites, and preventing the site you visit from knowing your IP, Tor Browser is excellent. The content of your activity on Tor is protected. The sites you visit do not see your real IP. Your browsing pattern is not linked to your identity through the usual advertising mechanisms, because Tor Browser also bundles anti-fingerprinting protections in the browser itself. It disables a lot of the JavaScript APIs that are used to fingerprint users. It constrains screen resolution reporting. It refuses to load many types of plugins. All of this is on top of the network-level anonymity. What Tor does not do is hide itself from your ISP. That's the gap. If you understand that gap and you accept it for your threat model, Tor Browser is a capable tool. If that gap matters to you, pluggable transports are the answer, not stacking VPNs or hoping no one is watching. Practical steps from here. Download Tor Browser from the official torproject.org. Always verify the signature. Never use a mirror without verification. Configure a bridge through the Tor Browser's connection settings if you need to hide Tor usage. Request a bridge through BridgeDB if you need a private one, or try Snowflake, which is built in. Understand that your threat model dictates the configuration, and reassess that threat model every so often because the landscape shifts. The broader lesson here, and this applies beyond Tor, is that encryption and anonymity are not the same thing. HTTPS makes your content private. It does not make your activity invisible. Tor makes your identity unlinkable to your activity. It does not make your use of Tor unobservable. Every privacy tool solves a specific problem, and the failure mode most users hit is assuming a tool solves a broader problem than its design actually addresses. Read the docs. Know what you're trusting. Configure for the threat you actually have, not the threat you imagine. And if your ISP is part of your threat model, don't stop at installing Tor Browser. Keep going until your mental model matches what the wire actually shows.